and I'm going to be explaining about my Summer Fellows project, proposal for it. I am proposing a text-to-IFC pipeline that can be used as part of the digital twin for increasing accessibility to folks with disabilities, as I've described in my application. So IFC is Industry Foundation Classes, which is a schema for the definition of building information models. The intent of this particular demo that I'm going to show is to demonstrate a reusable workflow which can be swapped for any AI model of your choosing. But in this particular demo, I'm using the GPT-4o Mini for the model, uh, which was of my choice, but you can swap it for a model of your choice as well. And possibly a fine-tuned model would work best for this that suits your use case. This is also extensible as the parser and converter are separate, so you can replace either part in case you want to implement this for another file format. The process I'm going to follow will be using an LLM to produce an OBJ mesh encode, extract the OBJ lines from the response, parse the generated vertices and faces, and use the IFC OpenShell API to wrap the mesh inside a minimal IFC project. And then I try to open the generated block in Revit or another BIM platform of your choosing. So the first part of this is to send a prompt to a large language model, save the full response into an OBJ mess or some other Word file. And in my process, I'm using the OpenAI client to pass the system and user messages. And this is a fairly simple script. There's nothing too complicated about this. Now moving on to parsing the mesh that the generative model generates. I parse the vertices and the faces into Python lists, and I save the summary to a text document. So this particular script returns only the lines between the first pair of backticks that the LLM response contains, and I try to parse it and clean it into a format that can be easily used to make an IFC file out of it. So this code first reads the entire text from the file with the messy LLM output, and then I extract the lines that I require, I debug them and parse it, and then write them to a new file, which is then passed to the next part of the script. So the mesh to IFC script, it wraps the mesh as an IFC faceted brep, which is essentially creating a minimal IFC hierarchy. It writes the generated block IFC file, and it relies on the IFC OpenShell API, high-level helpers. So this is probably the part of my workflow that I would call the moat of my process or the project, as this is not something that existing LLMs are trained to do, at least at least trained to do well, as of the last time I checked. Also, this is also the part where I can use the IFC schema to fine-tune my own model. So this project becomes an example of data being the moat to a LLM wrapper, for lack of a better term. Um, so why am I using an OBJ format for the initial generated mesh? It's because I found that OBJ has the easiest grammar out of 3D models. There's plenty of examples in web data, and current LLMs seem to be better trained to understand OBJ file formats for meshes, and they're simple to parse. And I'm using the IFC faceted VREP format as it is universally supported by BIM viewers. So the current code block is when I run it, it produces an IFC file, which is the generated block.ifc, and I will import that into a BIM platform of my choosing, which is Revit for me. It's taking a second, and I know the video is slightly going above 5 minutes, so excuse me for that. So as you can see, all this trouble was for just generating a small cube. So I'd like to show that the expectation for the project that I've been working on over summer is to first uh, train the model to better understand spatial semantics and generate a detailed block like this for a building of my choosing so that it can actually help the users. So you can see the expectation versus the reality I have at the moment. Well, this is still a work in progress. So the next steps would be to make the model better and modeling the building better, so possibly by fine-tuning with data from the IFC schema, fine-tuning my own model. Then I'll be looking into making a prototype that uses this digital twin of a real building with location data from a phone to see if the location can be tracked, essentially like how I mentioned in my application to make Google Maps, but for within buildings. So then onward to further, I can then forward from that, I can refine user experience for this project and add user experience driven functionality so that my proposed users can actually benefit from this. Thank you.